So this is going to go through mining and mining processes. And there's a lot to know about mining. So we're going to start just off with some general terms. So first is just kind of the definition of mining and what mining is. Mining is basically digging stuff up out of the ground. It could be surface, or it should actually say subsurface, not surface or surface, surface or subsurface, to get desired materials that you want out of the ground. These desired materials could be coal. It could be like fossil fuels like coal. It could be gravel. If you think about like when you see them making roads, they will put like gravel underneath. People put gravel in their driveways, gravel roads. So a gravel is, again, a desired material. Things like diamonds, again, could be dug out of the ground. Emeralds, precious metal, or precious stones like that. And like copper and gold, those actually usually come out. Sometimes gold can come as pure gold, but often it's a rock, which if you looked at the rock, a lot of times you would have no idea that there's like copper in it. And then they have to process it in order to then get the copper out of it. So that's what mining is, and that's some things that you would mine, which leads to the idea of ore. Ore contains the desired metal, but it's chemically bonded to other elements. So if I'm looking for copper, there's copper, but there might be some oxygen and sulfur and hydrogen and other elements bonded together. And again, it's not necessarily going to look at all like copper or at all like silver. It's going to look like a rock. But when you chemically separate, it's a chemical process, you chemically separate, you're going to end up with your desired material or mineral, and then a whole bunch of tailings or waste then. So that's what ore is. And when we look at ore, we will actually talk about two types of ore, high quality ore and a low quality ore. High quality ores have a high percentage of the target mineral or target material. They could sometimes be 70 or 80%. So if you think about that, if it's 80% what I want, only 20% of it's going to go to waste. We're going to go after high quality ores first in mining, much more profitable because you're going to sell that. You don't sell the waste. A low quality ore can be well less than 1% of the target mineral or material. And so an example I have here is gold ore. They often will talk about it's still profitable because of the price of gold to mine an ore that is 1 ounce of gold for every ton of earth. In there, even sometimes they'll go after ores lower quality than that. So if you think about that, if you do the math, okay, if you take 1 ounce of gold and you convert a ton is 2,000 pounds, and a pound is 16 ounces. So if you take 2,000 times 16, and you take 1 and divide by 2,000, and then divide that all by 16, and then you're going to make that a ratio out of 100. You're going to end up with 0.003125% gold. That's a tiny, tiny amount. So if you think about it, 1 ounce, a tiny ounce, and a ton of earth. And so you're going to end up with massive amounts of waste. So it's best to go after a high quality ore, but a low quality ore will still work if the mineral is profitable enough. So a couple more terms to look at is this idea of overburden and spoils. So if you look at this diagram here, it'll say like this active pit or this dig depth. That whole area above this coal seam is what's called the overburden. So that top area from the surface of the ground down, that's the overburden. And then the coal seam, and they will dig out that coal seam essentially. And so that overburden, they have to strip that away. That's topsoil, that's earth, that's habitat. They're going to strip that away. And when they strip that over and they pile it up, those piles are called spoils. So the spoils here are the piles of this overburden. So overburden is the stuff, the topsoil, the habitat, and just rock above the target of what you want, the ore, like the coal or whatever ore it is. And they strip that away and they pile it up, and that is going to be the spoils. Other mining terms are this idea of ore versus tailings. So the ore has in it the target mineral or target material, and then it's got all this other waste. And so here, to separate the ore from the target mineral, they kind of sort it out. In that sorting process, you get these piles of this waste, and the piles of the waste are called tailings. So that's kind of what you're seeing here is these big pile of this waste is the tailings that will happen. So that is ore contains both of it, and then you separate out what you want, and then these big piles of waste. And again, remembering if it's a low quality ore, the pile of waste, a entire gold mining operation might get, in the process of running, just a few gold bars in a day, and they've moved hundreds, probably more than that, probably thousands and thousands and thousands of tons of earth. So massive, massive amounts of land can be used in this. So in order to separate the ore from the desired waste, there's a couple processes. One is cyanide heap leaching, and the other is smelting. So in cyanide heap leaching, basically they're going to take cyanide, it's a solution, and they're going to take that solution and they're going to flush it over the ore. And when they flush it over the ore, there's a bunch of other processes, but basically that happened. But to keep it simple, they're going to get out the target mineral or target material, and then there's going to be this waste slurry. The problem is there's a lot of this waste slurry. And cyanide, if you look it up, it's a pretty toxic thing, pretty scary thing with cyanide, and it can run off into surrounding waterways. Cyanide heap leaching is very often used for gold and silver. So again, it tends to have massive environmental impacts, but it's often used for gold and silver. So that is cyanide heap leaching. Versus in smelting, this image here, what they have basically done is use so much fossil fuel that they took solid rock and they got the rock to melt. So if you think about it, a solid rock melting, that's crazy hot. Like you think about like on your stovetop, you can't get a rock to melt. Okay. Don't try it, or it's going to, it's a big fire hazard and such. There's not enough heat to do that. So there are a whole bunch of process, but basically they're going to try to take these rocks, melt these rocks, and then through different things, now that it's in a liquid state, they can start separating that out. This it uses massive amounts of energy, causes lots of air pollutants to be released. Carbon dioxide contributing to global climate change, sulfur dioxide releasing related to acid rain, particulates, a lot of really pretty bad stuff comes out of that. And so that is smelting, the way to separate it, which is going to now get us into the idea of what truly is surface mining. Surface mining is digging out a resource from the ground where the point of entry is the surface. Subsurface mining, basically they're going to dig a shaft down into the ground. I'm going to pause the video here, and then we'll come back and we'll dig into surface mining in just a second.